Hello, everyone. Welcome to this session. At Mobile Wallah, we are sort of always thrilled to partner with the Data Science Central folks. We've done a whole bunch of stuff with them, so very excited to do this. So this is the session on EDA and the workshop on EDA. And the way we'll run the session is, well, there are four of us on this. Anindya, Datta, that's me. We have Kajanan Sangar, who runs AI and ML in Mobile Wallah. He's sort of he and his team are really the main act in this. And then we have Akhil Mamen, who runs the product, basically who runs our Anovos product that we're going to demonstrate. And Datta, who's sort of in Kajanan's team and is sort of intimately involved with the development of Anovos. So that's the team. And the way we'll run the workshop is as follows. We're going to start off with a short primer on EDA, and in particular on how EDA applies to building predictive models, how EDA applies to the machine learning workflow. And then, once that is done, that should take about 20 minutes or so. And I am going to deliver that primer. You see sort of the first slide of that. And then once that is done, Kajanan and his team, led by Kajanan, will pick up the hands-on part, right? So let's start. So, all right. So this is, I think, the group that kind of we belong to and we run. So we always start off by inviting the audience. So those of you who already belong to the group, welcome back. And those who are not, we would love you to join our meetup group at the URL we are showing. And of course, you're welcome to join us on Slack, use Anovos that will demonstrate to you, give us comments, contribute, all that good stuff, all right? So let's get started. So we are talking about EDA, or exploratory data analysis, which, given the nature of this audience, I'm sure everybody knows quite well. And basically, EDA is looking at data to make certain judgments before performing detailed analysis on the data. So just to be sure, even though we are talking in the context of predictive modeling and AI and ML, EDA doesn't necessarily just apply to AI ML, right? I mean, EDA, before you do any statistical analysis, right? I mean, imagine that you're going to hypothesis testing, right? Before you do anything, to make sure that your eventual results are meaningful, you must make sure that the nature of the data that is fed into the analysis is robust, satisfies certain conditions, and EDA is the process to do that. And the purpose of EDA is to basically assess the quality of the data and also identify anomalies if they exist, right? Which of course would need to be fixed before diving into sort of the details of whatever you want to do, right? So that's EDA. In this presentation, of course, we are not talking about EDA as a broad field, and EDA is a very broad field. We're interested in EDA for building predictive models, right? So EDA, as it applies to data scientists who are going to use data to build models of prediction. So in this context, EDA has two sort of very specific goals, right? So one purpose of this presentation is to make EDA normative for you, right? EDA is a science, right? So now we are talking about the science of EDA in machine learning. So two goals for EDA for data scientists. First, you want to analyze the base data, and I say attribute by attribute, assuming the base data is columnar. It doesn't have to be, but almost everything I'm saying applies to non-columnar data as well. But it just makes it easier to have a specific, to frame the discussion in a specific way to make things clear. And anyway, our personal experience is that probably 80% of all modeling happens on structured columnar data. So it's the framing is pretty broad, right? So one goal is to analyze the base data to assess how well it lends itself to predictive modeling, right? So in order to build good predictive models, the data and the features that you're going to fit into the models must satisfy certain conditions. Otherwise, your conclusions won't be good, right? So one key goal of EDA is to analyze the base data to make sure it has those properties. And second, clearly, very few real-world based data comes in sort of model ready, right? So one of the goals of EDA is to detect those issues, the anomalies that exist in your data that make it kind of not model ready, and then fix them. Right? So what does this mean? So I wanted to make it clear with some examples. So what are the things you are looking for when you are analyzing the base data as a data scientist, right? So, and all of you probably, or majority of you know all of this, just establishing a platform here for future discussion. So for instance, are there attributes with lots of missing values, right? And if there are, you're either going to throw them away if you feel that they're unsavable, right? You can't do anything with them, you're going to throw them away. Or, you have an attribute with, let's say, 25% missing values. You might want to fill them in with something, right? You may want to impute those missing values. Number two, are there attributes with outliers, right? Basically, are the distributions super skewed? Well, multiple ways of handling it, could be you want to throw away the outliers, replace them with null, or you want to replace them with, some measure of central tendency of the column, right? Mean or median or mode. I mean, there are other ways as well, but bottom line, you either going to replace them with null or you're going to replace them with something else. Are there groups of attributes that are strongly correlated? Well, if they are, that just means that, not all of them, you don't need all of them in your eventual modeling, or to create features. You'll typically pick one, right? Which one will you pick? I mean, there are multiple ways. Maybe you want to pick the one with the highest information value. Are there categorical attributes that have very high cardinality? Because if there are, then we, most of us know that doesn't create a way of good modeling, right? So what you would normally do is, let's say you have a column with hundreds of sort of categories, right? So then what you would do is you typically do some sort of a transformation when the many categories will be mapped to some number of smaller categories. Let's say you have 300 different categories, right? You might want to replace them into 25 categories and give them numerical class numbers, right? So these are typically the examples of properties that you are looking for in the data before you start modeling with it, and what you would do if you find issues, right? So just wanted to make sure that's the purpose of EDA for data. Let's now actually dig in, right? So when we say, so what part does EDA play in sort of building a model, right? To understand that, let me acquaint you with sort of a fairly generic workflow of how models get built. Right? Again, most of you are, I have presented this a number of times if you've seen me before, and most of you are familiar. So, you have base data that you're going to use for modeling. The first thing you do in building a model is you bring in the base data and you ingest the data and you analyze it, right? And basically at this step, you're doing a 3-part kind of test, right? You analyze, meaning you check for specific, are there missing values, right? Then you assess health, which means the output of that analysis is, okay, there are 80% missing values or 30% missing values, right? So you get some output and you assess the health. And based on your assessment, you treat and clean. 80% missing value, can't do anything. Throw it, the treatment is just throw the column away. Or 25% missing value, let's clean it, right? And you run through this for every test you want to do, missing values, outliers, all that stuff, right? So what comes out of this step is clean data and model-friendly data, right? So you have checked in the data, you have tested it for anomalies, you've cleaned it, and now you're ready to actually create features with it. Feature creation itself has a bunch of different steps. We won't go too much into it, but I'm assuming all of you can identify. First is candidate feature generation, right? So you are trying to create a model. You're trying to create a model of, propensity to purchase something, or you work for a telecom company and you are looking for creating a model to predict churn, right? The first thing you got to do is to go through a process where you say, okay, these are the features that I think would be predictive what I'm looking to model, right? So if you are looking for a propensity to purchase a luxury item, you can say, okay, I feel that wealth, financial wealth would indicate would be a predictor of that, or other thing. Basically, this is a very ad hoc step where you're trying to figure out what is predictive of the outcome I'm seeking to model. And then once you have those feature labels kind of mapped out, through kind of an ad hoc thinking exercise, then you got to figure out, can I create those features from the data that I have, right? So basically, if let's say affluence is a predictor of something you're going to do, you're going to say, okay, the data that I just brought in, how can I use it to either create affluence or a proxy for affluence, right? So you got to get the data to map to features. And in this process, you might find that, hey, I thought something would be highly predictive. I simply don't have the data to even create a weak proxy for that. But it's so. But I'm so. I believe it so strongly that this is very good. Maybe I'm going to go outside and get more data, third-party data, to create it. Bottom line, you create your features, and then when you have created your features, those features themselves have to conform to certain structures to be able to then be fed into sort of learning techniques to create models. The features themselves, like the original data you read in, the features themselves are also data. So you have to check features for goodness as well. Do the features have missing values? Is it high dimensionally categorical features, all kind of stuff. So you do that, you treat it, and then what comes out of this step are model-ready features. And now you're ready to start modeling. These days you often put these features into a feature store. You don't have to. You can keep them in file systems or however you choose. But bottom line, then you get your the different learning techniques you're going to use. Maybe you're going to use logistic regression, or maybe you're going to build a neural network-based model. Bottom line, whatever technique you're going to use, you train them with these features. Basically, this is sort of known as the model pipeline stage. Create, test models. See if it's good, see if it's adequately accurate, and when this model passes those steps, you deploy it, and then of course operational feedback comes out of the model. Right? So again, I'm sure all of you know this. This is sort of a high-level view of the workflow in machine learning, and you can see that there are some of the arrows. The process arrows are blue. And that typically refers to what is known as a data pipeline in the machine learning workflow, where you are preparing data for use. And then the red arrows, I've kind of abstracted away the red part because we are primarily interested in the data part. But the red arrows indicate the model pipeline, where you're building the model, testing it, training it, testing it, deploying it, monitoring it, and so on. Right. So that's the part of preparing these, pulling in the data to the feature, which is really the data part that we are most interested in, where EDA is going to play a part, is typically, as you guys all know, is known as feature engineering. This is a really critical part of the model. And as you will see, EDA is where EDA will apply in model building is in feature engineering. And it turns out that feature engineering is perhaps the most important part of model building, right? Why? Because data and in turn features have the biggest impact on machine learning model outcome. And not only is it so it's really important that you have the right features, but the problem is that, as I showed you, the step is so ad hoc, right? Imagine the candidate feature generation stage, right? Which is one of the most key things when you are kind of conceptualizing what's predictive of the outcome that you are seeking to model. It requires sort of super deep knowledge of data sets, right? It needs, is very time consuming, is very error prone, right? If you make a mistake in thinking up of a feature, that's going to ripple through the entire model. It's very hard to operationalize because it's so ad hoc. Bottom line, I mean, feature engineering is important because the data and features are so important, and that's proven. And what makes it more complex is that it's so messy, so ad hoc, so time consuming, prone to errors, and these errors have deep impacts, right? And this is something I often show. So, and again, most of you would have heard of Andrew Ng. He has done a lot, written a lot in the area of AI and machine learning. In many ways, he's popularized AI and machine learning. And one of his podcasts recently that I was listening to, From Where These Are Stolen, he was mentioning that if you think of model building, right, 80% of model building is prep, which is the feature engineering part, and 20% of the model building is really action, where you're training, testing, deploying, and so on. But if you look at the work in industry, in academia, in research, 90% of all work in AI goes into the action part. What's a smarter learning technique? How do I train better? How do I, ML ops, for instance, how do I monitor? But very, very little, less than 10% of AI goes into the prep part, which is really 80% of modeling, right? So bottom line, I just wanted to make sure I'm framing the importance of sort of EDA to you. The data part, preparing features, is really important. And it turns out that data analysis, or EDA, forms a very critical part of this feature engineering process, right? In particular, EDA plays a role in two distinct parts of this workflow. First is here, right? So when you are pulling in base data and you are testing the base data, the core raw stuff that you're pulling in, for goodness, right? And this is typically, we call this pre-feature creation EDA, right? Because the purpose of this is you are outputting good data to create features. And then once you have gone through feature creation, you've got to test those features for goodness as well, which is this part that I'm showing now. And this is known as post-feature creation data analysis. Many of the underlying tasks are similar, but these are two distinct and two clearly identified tasks that you must perform. And clearly those of you who build models are already doing this. So you can see why EDA's data analysis is so important in feature engineering. And because feature engineering is so critical to model building, EDA becomes very important to model building as well, because data quality is so important. All right. So let me now take you through these two parts, right? So for EDA before feature creation, I'm going to try to make this very systematic, very procedural. What is it that you need to do? So you need to do kind of three things in this when you pull in the data. Right? One is you need to do basic understanding. You need to get a basic understanding of the statistical properties of the ingested data. Right? Skewness. Is it skewed? Are there missing values? I said skew, but what I meant is shape. Measures for central tendency, percentiles, shape. You need to do cardinality checks. These are all things, basic things you need to do in order to assess the quality of this data. So these are sort of basic understanding. And then once you have that, you need to do data quality analysis and treatment. This is central to good model building, right? And typically to build machine learning models, you do 6 kinds of quality checks, right? You check for nulls, you check for outliers, you check for IDness, you check for bias, you of course check for invalid and duplicate entries, and you check for stability, right? Most of you would be familiar with the top 5, perhaps not so much with stability. This is a fairly recent kind of understanding that practitioners and scientists have had this very important property. Basically, if your data is not stable, your model is not going to be stable either. But I encourage you to kind of read up on it, right? So we have done some pretty interesting work on this in Mobile as well. And then once you have, so this data analysis and treatment is, of course, you do it on an attribute by attribute basis. But across attributes, you need to understand associations as well. That's number 3, right? And in that, typically, data scientists look for 3 kinds of associations. You look for correlations and clusters, you look for information value, and you look for information gain. In the workshop, we'll go through all of these things, but I'm just trying to make it proceduralized and provide you a primer for what typically you do for EDA. So that's before feature creation. And once you have created the features, you typically look for you test those features for quality as well. And you typically do 5 things. You do, are my features stable? Do they have the optimal cardinality? Very high cardinality hurts. Do the features have missing values? You try to do outlier categories identification and dimensionality, right? These are the 5 tests you do, and depending on these tests, you run some transformation on the features to make them sort of, I would say, good, right? If you find anomalies. So hopefully these 2, one of the things that we are trying to contribute here is to make feature engineering and EDA much more procedural. So hopefully this gives you a framework to perform this, right? So now let's actually give you some of the issues, right? So fine, you need to do that, but turns out that you're going to do that with the tools and stuff available to you now. There are tons and tons of statistical tools available. But it turns out that these things are quite complex, right? So let me give you 2 examples. One from pre-feature creation EDA and one from post-feature creation EDA. So from pre-feature creation, let's take an example that's ubiquitous, right? Almost every data quality analysis will have this, right? Numerical outliers treatment. So assume your base data contains numerical columns, and you have to look for outliers, right? So how would you do it now? This is a fairly canonical example, and let's say you're using pandas, right? Which most of you are already using. So you'd ingest your data with pandas, and then you have to compute outliers. So you don't know yet what method will produce outliers. So you typically, and you know that percentiles, mean standard deviation, and quartiles are the normal ways to kind of compute outliers. So you'd compute the 5th and 95th percentiles, you'd compute mean, you'd compute standard deviation, 1st and 3rd quartiles. And of course, to do this, you'll write code in pandas, right? So showing you examples of the type of code you would write. Not hard, but you'll do it, right? Take time. And then once you have done that, you will compute the thresholds, right? So now that I have these bounds, where does a value have to be to qualify as an outlier, right? And not only that, you'd also identify what does it mean to be an outlier. If something is just on the 5th percentile, you might say, I'm not going to call it an outlier. If it qualified as an outlier by 2 methods, let's say by the percentile method and by the mean and standard deviation, so 2 out of 3 methods, I'm going to call it an outlier. So you're going to compute the final thresholds. You're going to set the rules. This is sort of the pandas code that you would write to do it. And then after that, you would apply outlier detection actually based on the computed threshold that you created. Clearly, there's no more room for me to put code in this table, but you can imagine there's more code there. And then based on that, you create the output, which you'd put in. You'd have your outlier absent data frame, right? The data frame that has the good data, right? So very, very typical. We do it every day. You guys, most of you do it as well. So I'm sure most of you kind of identified with it. It's nothing earth-shattering, but we use pandas. But you saw that even to do this one check, I mean, it took some time. You have to write code, and doesn't scale, right? And imagine that when you have to do all the 5 or 6 tests we showed before for all the columns, this would take a long, long time, right? So we believe that a much more ideal approach for numerical outliers should be much more simple, right? So you ingest the data, and there should be a function called an outlier treatment function that should be able to do all of what you just did. It should be able to identify numerical columns, pull them in, apply all the rules. All you have to say is that, that, hey, just set some parameters in the config. It'll apply that, do everything, something like this. It should look up, the outlier detection function that should, just one call you make, and it should, based on, and it should produce the output frame. Way simpler, way easier, much more scalable, much less time consuming. You didn't have to write all of that stuff, so you don't have the chance to make errors. So this is what we believe would be much better. And clearly we have, so we have open sourced a tool called Anovos, which actually allows you to do that, with the team will demonstrate. And then the second example that I'll show you, again, this is post-feature creation, right? Something that you always do is numerical data imputation. Basically, assume that you have a candidate feature that you have created, it's numerical, and it contains missing data, so you want to impute that missing data, right? So how would you do it now? I mean, again, you should identify with this very well. You would ingest the data, and first you put in a column determining missing values for all numerical columns, right? This is how you would do it. And then once you've done that, you would define some sort of imputer model and strategy, right? You're going to use mean or KNN or matrix factorization, however you want to do it. And all of that is going to, you have to implement a strategy using code in Pandas. And then you'd identify the best performing imputer model and run imputation. Clearly no more room to show code, but that's serious code as well. And then finally, you would output the imputed numerical column data. So just to do that, use Pandas, use scikit-learn, super manual, super time consuming. Instead of that, what if you could do this, right? You ingest data, you just apply one imputation function. That's sort of that infinitely more scalable, infinitely easier, right? And that's what we've been kind of been doing, and we'll share with you. So that kind of brings me to the end of sort of my part. Hopefully, there were two things kind of I wanted to do in my part. This part, one is kind of introduce EDA, and all of you know it, but I wanted to frame it in the context of data science. And the second part is I wanted to proceduralize kind of what does EDA for data science mean with actual steps, sort of prescriptive, and show you some of the problems if you want to do that. And we did that as well. So now what we'll get into is the workshop of doing EDA. We'll use this open source library called Anovos that we have GitHub'd a few months ago. And basically Anovos is a tool that allows you to build sort of resilient predictive models. But we'll kind of demonstrate the EDA part of Anovos to you. And you can find Anovos on GitHub at this location. And now I will turn it over to Dr. Kajanan and his team to take you through what hopefully will be a super interesting demonstration. Kajanan?
Yeah, guys, give us a minute. With me, Akhil also will be joining for this demonstration of this demo, which is our open source. Before we start, I just would like to make sure that you guys have installed Anovos. Have you? If not, yeah, there's a document should have been shared earlier to load the Docker and get Anovos get going. If you want, I can put it in the. Yeah, I don't think I can share a file here. Can you try sharing the file? That Anovos workshop, the Docker setup. Yeah, I'll put it into a Dropbox and share it. So the The instructions are there in that file. So can you see my screen, Akhil? Can you confirm the Docker?
Yes, I
So
can see
yeah,
your screen,
so
Kajanan.
this is the file. I mean, I'm not sure the organizers have shared this file with you guys as well. If not, yeah, that will just uh, give you the links, or feel free to go through install. I mean, we will start in another 2-3 minutes, but we will not be able to wait till all of you install if you haven't done so. But we just want to make sure that you have this file. Even after this workshop, you can go play with Anovos. Uh, so this file details how to do the step by step installation. So you don't need to do any local configurations. Anything is This is just a Docker image. You just load the image and play with it. So we don't want to make any changes to your local environment which you might have already set it up for your own day-to-day work purposes. So okay, that have you done that?
Yeah, everyone, there's a link to the EDA setup. You guys can see in the chat, and all the Anovos link you guys can see as well.
Yeah, okay. Okay, let's get going. So let me share the deck back again. Yeah, so with me, Akhil will join. So Akhil, so I will be just navigating the demo once he is finished with this deck. Akhil, you want to start?
Yeah, sure. Kajanan, you can put it on full screen for the
Yeah.
PowerPoint. Okay. Hi, everyone. I'm going to be introducing Anovos via a brief introductory demo following this presentation. However, do remember that after this session finishes, we will set up two separate demos. We want you to go and use the document, and please try out Anovos and let us know any feedback and any suggestions that you might have. So for this demo, we'll be employing a credit risk modeling as the use case and demonstrate EDA in the context of this use case. The base data set that we'll be using is from Kaggle, but tweaked slightly to showcase the wider functionalities of Anovos. Now coming to the data set that we have, yeah. Uh, so as you can see the table over here, the tabular data set contains loan application data with each row representing one loan. The attributes of the table include an identifier column representing the ID of a unique loan application, a set of attributes representing a variety of the characteristics of the application and the applicant, and a target variable representing the outcome we seek to predict. This is represented as a binary attribute, 1 for client with payment difficulties and 0 for otherwise. Using this data set, a loan provider would seek to build a model that predicts the likelihood of a default, given the characteristics of a specific loan application. So the workflow that we'll follow, we will start with ingesting and analyzing the base data set we showed you earlier. Anovos supports two forms of EDA, either through the Anovos generated reports or directly importing functions from the data analyzer module. We will show you both of these ways, pointing out key innovations along the way. Just so you know, Anovos supports the entire feature engineering pipeline we showed earlier in the presentation, not just EDA. But I will only be touching upon EDA. So now feel free to explore other functionalities once the demo is done and when you download it on your local stations using the Docker image. Now let's go to the notebook where we'll walk you through the EDA for the loan application.
Yeah, so yeah, before Akhil starts, so this notebook can be started locally in your machine, guys. If you have the Docker image in place, or what you have to do is do a Docker pull with this name Anovos / Anovos workshop latest. So this is the latest image of this. Latest image available in the Docker Hub. So then just do a once it is done. So just do a Docker run. So that's it. So with two commands, you should be able to make this image up and running in your Docker. Yeah, so it's very easy, but just making sure that everybody can follow this. Okay, Akhil, I think we can go back to the demo.
Okay.
So once it starts, or it will give you a URL. So this you ideally can copy this URL and paste it in the any of your browser of interest, and it should bring up this notebook up.
Okay.
Yeah.
So I'm hoping that the audience here has gotten the opportunity to actually go and download this or use the Docker image to set up Anovos on their system. If you haven't, please look at the link again, which was shared, and please go ahead and download it. In case you haven't, please just follow through while we walk you through the Anovos setup and demo, and then try it out again. So what we will start is we now the load data part is there, where we will talk about using loading data using the Anovos data load utility, which you can see over here. Clearly visualizing so many columns can get confusing and overwhelming. And that is why Anovos will provide a powerful set of EDA utility sense of this data that you will have. So in the EDA part that you will see after the load data, which will now start the process, you can choose to perform EDA in two ways, using the Anovos report utility or by calling the individual functions from the Anovos modules. We'll first look at the Anovos report that we have over here. We have two kinds of reports at Anovos. One is the basic report and the full report. So the basic report consists of the descriptive statistics, quality checker, and attribute associations. The full report has three more tabs, which will focus on data drift and a few more functionalities that we think would be very useful for a data scientist. I'll be currently using a pre-save full report constructed on the loan application data that we used before to demonstrate. So Kajanan, can you open the full report?
Yeah. So full report can be generated. I mean, full and basic report can be generated with a one liner of code, guys. So you have to just use Anovos basic report or the full report command, which is here. Yeah, Anovos report. So that is the command for the. But having said that, so you have to create the respective data points to generate this. So those are the data points which we generate. So if you do, I mean, very simple statistics which we generate to make sure that report can be loaded. So if you, yeah, so this the report looks like. Yeah, Akhil, you can go back to the.
Okay. So as you can see, the report contains 6 tabs. Over the 6 tabs which you can see on the top, starting from executive summary all the way to drift and stability. The second tab contains the data types for all the attributes, input attributes that we have, and we'll go through all of these different tabs in this demo. So let's start with the descriptive statistics. Under descriptive statistics, we can see a global summary of all of the data set, including the number of records and the number of attributes. That's the 10,000 or so number of records that you see and 30 attributes. The first thing the team here typically will focus on is the fill rate or the missing percentage for each attribute, because it can help me decide whether I want to impute the missing values or simply drop the attributes with low fill rates. If we order by missing percentage, we can see that, for example, around 70.5% of the entries are missing in attribute common area median. With this high missing rate, even imputation results may not be reliable, so it is better to just drop such columns. Now, coming to measures of percentile, personally, I also find the measures of percentile quite useful, in revealing whether there are any extreme values or not. For example, the order of attributes column, like the amount annuity or amount credit that you see there, are related to the amount of money. And if you scroll to the right, we can observe a huge difference between their 99th percentile and the max value, which indicates that outlier treatment will be required. At the end of this tab, we can also find the histogram for each of the numerical and categorical attributes.
Yeah, I mean bottom of this table.
Bottom,
guys,
sorry,
yeah.
bottom.
So you can click on the individual attributes and see how they are distributed and how many of them are missing. So it is grouped under the two categories as of now, the numerical and categorical. So you can click. Yeah, carry on now.
Yeah. So this is just to give you a quick visual understanding of your data as well. Now coming to the quality check, which is our next tab on the top. Yep. So till now, what Kajanan and I were showing you were examples of manually drawing the conclusions about the quality of your data by checking the individual properties. We also provide an automated quality check that presents the data quality in a consolidated manner, which can be accessed via this quality check tab. The quality checker reports quality issues along 5 dimensions: null detection that you see here, then IDness detection, which you'll see below, biasness detection, invalid entries detection, and outlier detection. So for example, in the outlier detection, it automatically detects outliers, and if treatment is enabled, it automatically treats the identified outliers using the method that the user gets to specify themselves. While these are just a few of the examples, the quality checker includes a comprehensive list of data quality assessments. We should point out that this automated, comprehensive quality checker is a key differentiator of the capabilities in Anovos. By automatically orchestrating a comprehensive set of checks, users of Anovos improve the efficiency in their step, and it will reduce the chances of any downstream errors. After the quality checker, we move on to another must-perform set of tests for data scientists, that is observing and understanding the attribute associations. So that is our next tab. So in Anovos, we allow attribute association analysis via a number of techniques, namely correlation matrix, information value, information gain, and variable clustering. So let's look at correlation matrix to start. We see that the correlation coefficient between the second row, amount credit, and the third column, amount goods price, is more than 0.9. And users can actually consider dropping an attribute if it is so strongly correlated with one another. Moving on, let's now look at analyzing associations from the information value perspective. That's the drop down there, yes, which is used extensively in the credit scoring domain to select the important features. Under IV calculation, if we order by column IV, we can see that attributes related to external source are the ones containing the most information value. Similar analysis can be done from information gain perspective as well. So another technique which we also allow you to do is variable clustering. Although computationally a bit more expensive, it is a good alternative to correlation matrix to see the groups of attributes which are closely related to one another. Intuitively, it groups correlated attributes into a number of clusters. In this case, 4 attributes related to the amount of money have been classified into a single cluster. So that you can also see that in the table above. Like you can the 4 attributes related to money, and we also have a visual representation of it. So After the attribute association, another thing that is a key differentiator is our final tab, which I want to draw your attention is the drift and stability. This represents an entirely new innovation that we have introduced here in Anovos. Because data drift is one of the most common causes for the lack of resiliency of models in the production environment, it is necessary to understand the driftiness of data so that it can be factored into the feature creation process from the beginning itself. To report drift and stability, we have generated simulated historical data from our current data set. In a real-world environment, data will naturally evolve over time, and these functions will be organically computed. The first component is data drift analysis. It compares the drift between two data sets and summarizes the attribute-wise drifting into statistic metrics versus four distinct distance measures that you can see in the columns here. Intuitively, the larger the value, the larger drift is observed in the specific attribute between two data sets, which are usually modeling data and prediction data. To have a better understanding, we can visualize the distribution for each attribute here if you scroll down. A little more down.
Yeah,
So for
yeah.
example, external source 3, we notice a significant difference between the two distributions. So the second component is data stability analysis. The difference between data stability and data drift is that drift compares two data sets, while stability compares along a series of data sets from time period 1 to time period n. In general, if the stability index is smaller than 2, we can interpret it as unstable. Now we'll order by stability index. In this case, the common area median is detected as unstable because it has a number greater than 2, a distance greater than 2, meaning it is likely to drift with time. In contrast, a stable data item such as amount annuity is less likely to drift over time.
Yeah, you can select here and check also.
Yeah. So amount annuity is the one that we think will be less drifty.
We give the order of stability. Yeah, so if you are interested in knowing how this stability is computed, so it's a mean standard deviation, and so there's a formula for that. So you can go check that in docs.anovos.ai. So all the details are there under the drift and stability part. Feel free to check how do we do this feature stability estimation. So there's a formula we use this. So yeah, this is, I mean, we just don't do like a just a stability index by ourselves, or because of we that did a thorough research and came up with this formula.
Yeah. So again, this is one of the key innovations that we have introduced, and I think this will be of very high use to any data scientist who wants to understand the driftiness and stability of the data set that you are working on. So this is the way we have our reports, and this was a quick walkthrough on the full report that you can create using Anovos. Now let's head back to the use case notebook. Yeah. So as I mentioned earlier, the user can choose to do analysis either by studying the report that we just showed you, or by calling the individual functions from the Anovos modules. So now I want to actually show you the second way, which is where we'll do a deep dive into using the individual modules, and we'll focus on outlier detection function. So we will first detect outliers via the measures of percentile. So let's take a look at their distribution first using measures of percentile. We can see here that there are mostly negative values. According to the dataset description, these columns represent the number of days before application date. Therefore, all values should be 0 or less. This means that positive values observed in days employed are invalid. Also, day's birth, which is mentioned in the row there, is the applicant's age. If we look at a minimum value, which is the maximum age in days, it is greater than 150 years, which is clearly incorrect. Days last phone change is when the users last change their phones. The minimum value is approximately 10,000, which is equivalent to 30 years. And this doesn't sound right either. All of these above are manual observations that we are making, and it is very easy to miss out on some of them. So instead, we will use the quality checker outlier function, where we have developed an ensemble technique which takes multiple statistical methods into account for the detection purposes, including percentile, standard deviation, and interquartile range. So now let's look at measures of percentile again to see if they have been treated properly or not. Here we can see that the minimum values are not that extreme anymore when you look at the table below, but unfortunately we can still see suspicious positive values in days employed because it should all be negative. Most likely it is because that value appeared for quite a few applicants and the default detection configuration didn't recognize it as an outlier. Thus, as we mentioned, we can modify the config used in detection. In this case, we change the minimum validation count from 2 to 1, which means that a value is an outlier if even one technique calls it an outlier. And after applying the function again, we can see that there are no more positive values in days employed. There are a number of other key capabilities actually in the data analyzer module, such as the invalid entry detection that can use regular expressions to identify invalid data entries. So in the interest of staying true to the time that we have been allotted now, we'll skip them now, but hopefully you can try this out at home and give us any feedback and any kind of suggestions that you would like to see as well, that you would like us to add on Anovos. So that ends our demo, which is only focusing on EDA. Thank you, everyone.
Yeah, so that is covering especially the EDA guys. So apart from EDA, you can do a full workflow from EDA to feature identification to transformation and dimension detection. So we are just not covering them, but if you look at this demo notebook, you will understand how do we do that. Especially we introduce another cool feature called Feature Explorer, which is about you just for example, you have been given a problem to solve, for example, credit risk modeling. So you just list out the features which are heavily used in such cases. So just input the industry and the problem definition. So it is a natural language processing system. So it will list down all the features which are used in outside industries to solve such problems. Then you should be able to start. And also you can input your current data which you have with based on your data dictionary. We will tell that what are the potential list of attributes to start off with in your modeling. So that is that feature also there. So those are some of the cool features we introduced, and we will do a mapping here showing that okay, these are the attributes you have, and these are the features used outside and what is mapped to what. So for example, if you see count children, so is the one which you have in your data set, and there's a number of dependencies used as a feature in solving this kind of problem. So we are able to match that. So this is like a really a semantic mapping, not just a text word match. I mean, it's not a one-to-one word match. So yeah, that's, I mean, with the limitation of time, so we might not be able to uh, uh, fully cover the whole notebook. But feel free to reach out to us if you have any question. Post it here so we can answer for another 1 or 2 minutes. Um, yeah, and also Anovos is powered by Spark because of the scale of the data which we handle internally in Mobile Wallah. So it's in petabytes. So we need a scalable feature engineering library, so which we use, which we started building internally and recently open sourced. So go have a look, and also we are heavily working on this to come up with more optimizations to this library, as well as we might come up with some other lighter versions also. Go give us a star to us if you like it, or feel free to make any issues if you encounter any issues. That would be greatly appreciated. We recently only launched this open source, but a lot of engagement is happening. Yeah, so feel free to reach out to us if you have any other questions or concerns in our Slack channel also.
And it is anovos.ai. Please go have a look.
Yeah, so we have
and-
all the details here and also AI. So you can have the docs here, how to use. I mean, Anovos is tested across all the platforms. And you can run it in EMR, Databricks, Kubernetes, Colab, in your own Spark cluster. So this is like a very enterprise-driven version. Um, so we do, because we internally run this in on our data, which is in a massive scale. Minimum is hundreds of GBs, our minimum data size. So we are kind of people unable to uh, stand with the pandas. So that's the reason we developed this in Spark. The Spark is the underlying data distribution framework which we use.
And please feel free to also give us any feedback on what you would like to see, in addition to what we currently have. Let us know what you like and don't like also. Looking forward to your feedback, because that will only help us grow this open source project that we're working on.
Yeah, we have if you have any issues, feel free to reach out to us in our feature engineering Slack channel. I think Lori has posted that here. I'm checking again. Yeah, it's here. I can post it again. Feel free to join there, raise your questions, doubts, or any other issues you have. We will be happy to answer such. Okay, guys, have a good rest of your day. If you are in states, if you are in other parts of the world, good night. Bye.
Good day, everyone. Good night, everyone.